In this video, I'll show you how shapes and planes create tension. And this is important for balance in the picture and for movement. And it's in my book, Ellen's Guide to Design Elements, which is $5 on Amazon. Here are some main types of tensions. There are point thrusts, like an arrow or a steeple, that forms a strong directional pull, and it should always point toward the focal point, not out of the picture. Then we have centripetal thrusts, like a spring that's stretched, and the viewer expects the spring to go back to its original position, relieving its tension. A pressure thrust is like a balloon or a ripe fruit. It has forces from the center pushing toward the periphery. These forces are evenly and widely distributed, and it could look like the form is about to burst. A shape consists of a boundary which provides its orientation and the internal tensions that I show with these arrows. The greatest tension for a rectangle is felt along its long axis, with less tension perpendicular to that or going to the corners. So this makes it a dynamic shape because it points in a particular direction. The force gets greater as this rectangle lengthens. A square has tensions on its sides and its corners, making it a static shape with a tendency to rotate. A diamond has strong forces toward the corners, since these directions are also horizontal and vertical, so the diamond seems more inclined to rotate than the square, since it's balancing on a point and its left to right pull is stronger than for a square. This triangle appears tilted, since its longest axis is diagonal. Forces go to the corner. If it's a sharp pointing shape like this, its main force is along its axis. But if it's a squat equilateral triangle like this, the forces seem to push outwards and upwards. A star has forces shooting outwards from its center to its corners, so it usually doesn't have one dominant direction. And the star, like the diamond, has a tendency to rotate, although it may appear more stable than the diamond if it's resting on 2 points, as this one is. When a shape is turned upside down, like these triangles, then it looks very different. This triangle is stable, whereas this one is balancing precariously on this point. When you turn faces upside down, they can appear frightening. For a painting with a frame that is hung crookedly on the wall, even though the diamond in the middle could be a staple figure, it looks like a tilted square since it's parallel to its tilted frame. Now, the artist should have frames of reference that compensate for one another or are subordinate to one another. So here we have 3 different planes. 2 of them make an X, so they sort of cancel each other out. And as a result, this green line seems to align with this plane in the back with its horizontal and vertical lines. Here, I have diamonds that are linked together, so they look relatively parallel, even though they have somewhat different orientations. A plane not only has internal forces, as we discussed with shapes, but it also has external ones, as I show here. And they're most powerful perpendicular to the surface. So this green object is placed so it is affected by external forces perpendicular to the plane. So it has a friendly attitude with the plane, like facing your body towards someone when you're speaking to them. But this object over here has an unfriendly position, like turning your body 90 degrees away from your listener. And the same relationships here occur with this horizontal plane, where this is perpendicular to the plane, so it has a friendly attitude, and this is an unfriendly attitude. Let's say your painting looks like this unfriendly attitude here. You would only have the internal forces pointing toward the object. The image would be very directional, but it would lack tension. With the friendly attitude, there's a perpendicular pull between the internal forces following the plane and the external force going to the green ball. And the artist can manipulate these tensions. When two planes meet at a T, the internal forces of this plane either dissipates or connects to the internal forces of this back plane. So the movement circles around to the front. The movement goes around this object, which is placed in a friendly attitude toward both planes. And this is a good position, for example, for a still life object. When two planes are separated, several circular movements are possible. With a small space, there's no movement from front to back, but as the space gets larger, forces circle around it. And there are two friendly spaces or places for the ball, right here and right here. Now, if the vertical plane were taller, then there would be a stronger pull upward while still retaining some of this horizontal movement from the internal forces of the plane. If the vertical plane were shifted to the right, forward movement increases, making the area in front more important, while still retaining some movement in the back. If the vertical plane were shifted toward the left, the rear space would become activated. In this situation, we have a vertical plane here and another one perpendicular to it, but this time we have an overhang. And the overhang helps direct movement around this vertical plane. So we have one favorable spot here that's perpendicular to both planes and another favorable spot over here. Now for the V shape, where two planes are upright and form a V pattern, the green dot in front is the strongest spot for still life since it's friendly or perpendicular to both planes. And placing it away from that spot, let's say over here, may produce tension as we expect it to spring back to this original strong position. And there are also green spots over here and here, which are friendly but only to one plane, so their positions are less strong than the green dot in front. And this red dot is a spot that's unfriendly to both planes. With an interpenetration of planes, they maintain their internal forces without dissipation, like we saw with the T configuration. So there's a pull between the internal forces of both planes, creating tension in space. Now for a translucent set of planes, we can compare the movement of a plane in front to its movement in back, and interweave the planes, interweave them from back to front, horizontal to vertical, and try to provide unity and intensify the space. You want to rotate it around to find where the space is best activated. So check out my book on Amazon, and please remember to subscribe if you like my channel.